All right, composite functions. So we know what a function is already. Composite function is when you have a function within a function. Okay, so write this in. Composite function is a function within a function. What do I mean by that? So for example, you got log e of x. You learned that last year. That's a logarithmic graph. And then if I substituted x as another function, so for example, I might say log e of sine of x. So now you have a sine of x function within a logarithmic function. This is called a composite function. Technically, this is a composite function as well. Technically, this is a linear function within a log function. But because you already know what this graph looks like, we usually just say logarithmic function. This one, you may not. You might not visualize what this actually looks like, what the limitations are, but that's called a composite function. But not all equations that I make up is a function. It has to work for it to be a function. So here's an example. So first part of the exercise is learning to write a composite function. Here, let f of x equal to sine x, so sine graph, and let g, so g of x, be a quadratic graph x squared plus x. Then when I say f o g of x, what this means is, and how it's read, is it's read f of g. That's how we read it. Okay, so what I'm saying here is f of g of x is equal to, and what this means is I have the function f, but inside it, we have g of x. What's f of x? F of x is sine of x. Okay, so f of x equals sine of x. But within this function, I have g of x. So here, this is where I write the g of x in here, and that becomes x squared plus x. This is the composite function. When you say f of g of x, that's what this is. Okay? Normally, it's written with square brackets on the outside as well. Normally, this is written like that. F square brackets g of x inside. That is called a composite function. Okay, so this is composite. But if you switch it around, if I said g of f of x, okay, this now means your g function, I'm going to substitute the function f inside it. Okay, so for all the x's, I'm going to replace that with f of x. So that means, over here, I'm going to do square brackets again. Inside it, I'm going to replace all the x's with f of x. What is f of x? Sine of x. So if I wrote it again, first one is x squared. So instead of x squared, I now have sine of x all squared plus x again. I'm going to replace that with f of x. So it ends up being sine of x. Okay? You can also write this as sine squared x plus sine of x, if that's how you've learnt it previously. That's okay. All right, but when you see that little square on top, it actually just means sine of x all squared. That's what it means. All right, so first skill in exercise 1E, writing composite function. But it doesn't mean that if you type this on Desmos or on your CAS calculator, that it actually can sketch it. Because in order for it to sketch, there is two conditions for it to work. Okay, and that's what you're practicing today, or technically 1E. All right, let's have a look. What are the conditions so that when you type in your CAS, it is definitely going to work, or the domain for it will work, okay? For a composite function, f of g of x, to be defined, notice the one I'm using f of g, okay? Because if I wrote it the other way around, then the rules also flip around as well. Okay, so notice it's f of g of x. To be defined, it must satisfy two key conditions. Number one is the most important one that you have to check first. Okay, it is the range of g of x needs to be a subset of the domain of f of x. Write that in. That's one of the most important first steps in exercise 1E. Okay, so the range of g of x has to be a subset of the domain of f of x. Which also means, and this is what examiners do for a typical exam 1 question, they'll switch that around because most students will memorize this. Most students don't understand what this actually is saying. So they'll memorize it and then exams, they swap it around. So they'll say, state the limitations or define for g of x, so g of f of x to be defined. And then students will write this. And that's wrong. Okay, because this is now flipped around. This one is now, the answer for this one is, it needs to be the range of f of x, needs to be the subset for the domain of g of x. Now that's hard to, I don't want you to memorize it. I'm going to try to teach you to understand why is this the case. Because if you understand it, then the stuff that I'm talking about, you don't even need to memorize these two. Okay, it just makes sense. So I'm going to show you why is it the other way around. So if it's f at the front, seems like it's g, the range of g needs to be the domain of f. And then if I swap this around again, same thing. It needs to be the range of f to be the domain of g. Why is that? Okay, so let's have a look at an example. And I like this machine picture, and why I'm following from 1C is to help you link the two. Yeah, so here we go. First one, f of x is 1 on x. 1 on x is a rectangular hyperbole, so I'm just going to draw on the side so you can visualize it as well. This is what a rectangular hyperbole looks like. That's f of x. Okay, so right here, f of x. Then g of x is over here. We're going to do g of x in red. That's your square root function. Okay, so far so good. Then when you say f of g of x, it means that for f, I'm going to substitute g of x inside it. And that's one of the key things. You're taking root x and you're putting into f of x. This is what the function will look like. It will look like 1 over, now instead of x, I'm going to substitute it for root of x. That's called a composite function. So right now that's a composite function. We don't need to sketch it yet. We're just going to answer a couple of analytical questions. Here we go. Let's look at the first function. Rectangular hyperbole. What's domain and range? Look at the graph. What's the domain and range? Let's go, Vibha. What's the domain and range of this graph? Good. So I can see that for the domain, I can have all numbers except for, and there's an asymptote here, at x equals 0. So it can't be 0. So excluding 0. Good. Range. It's the same. Very good. So the range is all real numbers except 0. So it looks like you can take any number you want, except there's an asymptote at y equals 0 as well. Cool. Let's do the next one. Domain and range of g of x, which is the square root function. What's the domain and range of this one? Let's go with Sarush. Very good. So we can have r plus union 0. Remember, you can include 0 as well. So it's all positive values including 0. And it's also the same for both. Okay, so here we got r plus union 0. What I want you to see here is we're saying we're doing f of g of x. So the range of g of x, which is this one, needs to be a subset for the domain of f. Now, why is that? So here's the logic. You've got f of x, right? But before you get f of x, you had to substitute. You had to figure out what g of x is. So the first function was actually g of x. So g of x comes first. Then you take g of x and you substitute it into f of x. True? That's why you wrote before f of g was the same thing as writing f bracket g of x. Can you see this is the first thing that you're doing? You're working this one out. This is the first thing. That's the first function that you deal with. So if as soon as I choose an x value, if I said x equals to, I don't know, let's say 4, I have to put into g of x, and then it spits out a number. Then I take that number and I put it into f of x. That's how the order works. True? So that's why it matters that when you put in a number, so let's say x equals to 4, you put it into the machine. Then you say, well, g of x is root of 4. Root of 4, again, we know this is a function. So it's a square root function. It comes out one value. What's root of 4? Whoops. What's root of 4? What do you get? 2. So it spits out a 2. But remember, g of 4, isn't that the range? That is literally, so this is the domain. That's the number that you put in. That's the domain. And then it spits out a y value, which is the range. This is why it's the range, the number that spits out of g of x needs to fit the domain of the second one, because now you're putting this range number into f of x. So again, this is now the domain. Does that make sense? Why the rule says it has to be the range of g of x needs to fit in here. But what's the limitations for f of x? There was only one thing. Domain can't have a 0. So as long as I don't put a 0 in, the machine won't break. As long as this doesn't equal to 0, it's all good. So if I had 2, 2 is good. There's nothing wrong. We said here, x can take any number, and it can be a 2. So if I put a 2 in, it's okay. I can have 1 on 2. That's all good. 1 on 2 spits out 1 on 2. No problems. So the problem only occurs if I substitute it as 0. See, if I substitute it instead of a 4, and I start off with a 0, you sub in a 0, all good for g of x. I can do square root of 0. Spits out g of 0 is 0. Great, but here's the problem. So as soon as I sub 0, so the range for g of x, that's 0, into the domain of the function f, there's a problem. This now becomes 1 on 0. And 1 on 0 is undefined. So you don't actually even get a coordinate. That's why we say it's not defined. So the first thing is where we say, for a composite function to be defined, meaning that every x value you chuck in, there is going to be a y coordinate that comes out, because that's what a function is, right? If that is true, if this first condition is true, that means these machines should work no matter which number you chuck in. But as soon as you find an error to it, you have to fix that. And that's what 1e is about. That's the essence. The essence of 1e is that you need to fix the range of this function so that it works. Okay, and that's one of the most trickiest part that I find. If this is the first time you're doing it and you're not good at drawing graphs and you're not good at your domain and range, this is one of the biggest hurdles students go through. It's because you need to know what you need to fix. Here, the range is the problem. I can't have r plus union 0. I don't want this to be a union 0. So that means in this graph, I don't want that to be an inclusive one. I need to change this graph so that it is open circle, so that I don't have that 0. But the only way to change that is here. Don't have, also not there, here. That was the problem. So for g of x, I had to fix this to then fix my range. See, if I don't want that union 0, if I don't want that 0 there, then I needed to also cross off the 0 here. And that is the skill, which is really hard. I'm not saying it's easy for the first time. So the answer for this question, if they said to make it defined, if I want f of x, f of g of x to work, then the domain should be, so f of g, if I wrote it as a function notation, it should be r plus mapping to r, because I can't have this section here, of f of g of x, which usually they call h of x, is equal to 1 on root x. That there, me fixing that domain there, me fixing this bit, will now make sure no matter what number you pick, it will always be range of g fits the domain of f. Okay, now I know we're running short on time, but that is the essence. Next session, I'll do the problem on the next page, because the next page that's where you really practice. And the questions in exercise 1E, that's what you want to master. So if the things I'm saying right now is like a bit like pushing it, that's what I want you to practice. Spend your time here, because it practices your domain, your range, sketching the graph, using set notations and function notation, all of it in one. But in order to get there, you have to do 1 A, B, C, D. I'll say 1 A, B, C. Okay? So that's the goal. So next lesson, I'll do this problem with you, unless you've gone ahead and you've done it yourself. But that is the essence. If you want to go ahead and you don't want to wait for me, I've got previous videos here ready, okay, with some examples, and I'm guiding you. So watch those videos if you want, and then you can see how I go through the conditions. Okay, so I'm going to wrap it up. It's 11:27, and that is how methods is going to run. It's about 2 exercises per session. I do spend most of the time talking. You do take notes, and most of the time you're going to have to do it at home. You're going to have to watch videos, practice at home. So ideally, as we're going through this week, eventually what I wanted it to be is that you watch the videos in advance, you come into class, and I just work with you. So you get more practice time rather than just watching me do these notes. Okay? So next lesson, if you can watch in advance, then all I do is I'll just ask those who've watched the videos and were ready, do your work on this side. Those who haven't, so to be, and I'll then teach to half the class. Okay, so it's up to you. If you want to come prepared, watch the videos in advance, then you use the session to practice, or you come to my lesson and I guide you through the notes. Okay? All right, it's 11:28. Let's start packing up. I'm going to stop the video.